Hello, this is Zakar here, and today I'll be discussing a sort of new technology within the chip industry, and that is known as HBF. It stands for High Bandwidth Flash. As I'll discuss later in the video, it is connected and sort of related to HBM, which stands for High Bandwidth Memory. But this thing, HBF, this new technology, shall I say, is a little different. It's its own thing. It has a few other things. I'll discuss it later in the video, what it is and how it works and its benefits over HBM as well. So starting off with some basics here. So HBF is yeah, as mentioned before, HBF was inspired by HBM, which stands for high bandwidth memory. And the reason you would use these tools, and both of this goes for both of them, HBF and HBM, is because you can make AI more efficient in terms of memory storage. So essentially, they're used for designing AI, and specifically the memory sector of making AI, making more memory storage for AI. That's what they're used for. They both have essentially the same purpose, HBF and HBM, but one they're used for different situations though in the industry. So what is HBF? It stands for high bandwidth flash, as discussed before. It's a type of memory architecture that is based off of NAND gates, and yeah, it's used for storing AI memory data. Here I have an image showing HBM, high bandwidth memory, and how that's arranged and structured. So the key distinction here is that HBF is created off of NAND gates, and HBM is made off of DRAM gates. So that's something to keep in mind. There are two different memory architectures, two different design structures. So now I'll discuss the function, what HBF does, and how it works, and that kind of stuff. So, for some context, HBF is a new technology. It was recently created, and it's still rapidly evolving. Being improved and all of that. So HBF, it functions similarly to how HBM functions and has the same purpose as discussed. Now I'll discuss some differences that HBF has over HBM. The key distinction is that HBF is generally known for storing more memory data than HBM, and it helps improve AI by making the AI work faster as compared to HBM. So yeah, HBF is still being tested as of May 2026, but next year it's expected to come out and be a real technology out in the industry, that kind of thing. As of now, it's more of a testing thing. Still, it's still being tested and experimented on, that kind of thing. So HBF now, this is something about how it's created and all of that. Yeah, as discussed before previously in the video, it's HBF is made off of NAND gates, right? And those NAND gates are basically 3D stacked. They're stacked, connected as a 3D object, basically. Usually they're around 8 to 16 NAND gates, and the other thing, a key thing to understand is this thing called CSVs. It stands for Through Silicon Vias. Basically, what that is uh, it's this technology that is software that allows for different layers to be connected to the base of the logic chip. Basically, make sure that everything within that HBF system is plugged in correctly, designed properly. Everything's the way it should be, basically. So here I have some images showing how HBF is stacked, and here I have another image. This is more of the image of the 3D view. This is more of the kind of laid out view, I guess, if you will. Okay. Now I'll discuss. I'll make like a brief comparison between the two, so between HBM and HBF. So before I dive into the comparison, I'd first like to discuss something about HBF, how it's designed. This is more on the chemistry perspective, I would say. So HBF, in order to design technologies such as SanDisk's CBA, and that's CMOS directly bonded to array, different technologies like that. That's one example of that kind of technology are used to connect the NAND gates to the logic chip, and this makes sure that there are no defects in the HBF and everything's connected the way it should be and correctly, and basically everything is good within the HBF and the way it's all connected and all that. So as discussed, now I'll discuss I'll go over the HBF and HBM differences and compare them essentially. So core base, like this is essentially how the device is created off of what basically. So the HBM is based off of DRAM. Okay, and DRAM has low latency, but HBF is based off of 3D stacked NAND gates, and they have a lot of density. So both of these are good for certain situations, but you would use HBF for large language models, so the LLMs, specifically that version of AIs, where HBF would be better because it has high density, and large language models tend to prefer that kind of thing for inference. Now I'll discuss the engineering behind it. So HBM is made to be more of a fast device. It's made to be quicker and as fast as it can be, essentially. And that's because it has a lot of DRAM dies stacked to it. Now,